Good afternoon and welcome to our webinar on this cloudy and soon to be cold Wednesday afternoon here in Toronto. And we're glad to have you here as part of the group. I'd also like to welcome both Gavin and Paul Dombrowski from ISOTEC into the conversation today. Gavin is one of our remedial hydrogeologists and Paul is a remedial engineer with ISOTEC, a company that we often get involved in our remedial projects and enjoy the conversations that we have in that context. So before we get started, there's a couple of housekeeping issues. As always, I like to provide a perspective on land use. I don't know about you, but I prefer to take my holidays in provincial parks where there's lots of trees rather than at my contaminated site projects. And I'm sure we all kind of feel the same way. And that idea of land use where we're able to protect some of the more valuable features of our natural environment goes back a long way, including to the first peoples who used this land, the Mississaugas of that first credit. And in your area, I'm sure there's others. So we'd like to acknowledge that that we are part of a long tradition of trying to promote responsible land use through the things that we do, and to restore some of the things that have been broken in that process. A couple of other housekeeping matters. There is a chat function that you can use to communicate any technical glitches to the team, or more appropriately, be able to ask us any questions that you have leading up to and during the Q&A session, which is at the end. We'll try and address relevant questions in the middle of the conversation if we can, but for sure we'll pick them up at the end. So today's agenda is to start what hopefully we can fit into a 40-minute tandem conversation, mostly between Gavin and Paul Dombrowski, as they go back and forth to discuss 3 different sites that they worked on together. And then we've got some time at the end for a question and answer. Once the webinar is closed, you'll be prompted for a short feedback survey, which is designated to take no longer than about 3 minutes. And that'll help us improve and identify areas of interest for the upcoming webinar. At the end, we'll also provide you an on-demand recording of the webinar if you want to go back and revisit some of the topics that we discussed. And we'll also hopefully be able to give you some ideas about what some of our upcoming webinars are. So stay tuned for that part. Thank you. And so on that note, if we can go to the next slide. So AEL is a consulting engineering firm that's focused on innovative land restoration solutions, and we do that through the implementation of site assessment and remediation. So that focused on risk management around environmental issues on a site is something that's embedded in our culture and something that we hope we bring out in this session. Next slide.
Well, Paul, I just want to thank AEL for having ISOTEC be part of this conversation, and just the ability to introduce ourselves to the audience. ISOTEC is a full-service remediation firm, and with experience implementing and designing a broad range of remediation technologies. Our team includes recognized experts in the field of in-situ remediation. We have experienced field staff, and many of our staff have been with us for 10 to even 20 years more, implementing remediation in the field and the pitfalls and the challenges that goes with that. We have an impeccable safety record, and we work on projects across the US as well as in Canada, including a number of projects where we partnered with AEL in Ontario in supporting the site cleanup process.
Great, thanks very much, Paul. And we'd echo again the successful collaboration we've had with ISOTEC on a number of our projects, and hopefully that'll come through in the project descriptions that we have today. If we can go to the next slide. So again, talking about our theme of environmental knowledge, and particularly in this case, what does risk management look like? In the context of remediating sites, we try and bring the perspective of managing risk rather than solving a particular issue to a predetermined level, like a cleanup criteria or something like that. This both allows you to manage some of the issues that come along with that. And if we can go to the next slide, we can see what those issues are. So we try and bring a holistic approach that looks at more of a property life cycle and risk management regime that sees that property right through the entire cycle. And then, of course, it restarts with either new owners. But that acquisition, ownership, and divestiture is different for every owner. It's also different for every site. So we try and understand what our clients' requirements are and build that environmental due diligence and knowledge, and be able to come up with risk management strategies that make sense regardless of where you are. But again, knowledge is the key, and better information makes for better decision making. Next slide. So how can we be proactive in that process rather than reactive? We like to use the analogy of what we like to call the project management trifecta, or the three things that you control in any project, which is budget, schedule, and outcomes. And then to manage those three things to create value either in the purchase or the divestiture process. And then also allow owners or occupiers to operate in a way that prevents negative impact or decreases that property value over time by building in systems that manage that. And then also, we're always aware of the need in our current environment for environmental indemnification with respect to property sale and divestiture. So we like to make sure that that gets identified up front and then to manage that in that process. Next slide. So how does that fit into the risk management process, or really into that whole regime of environmental due diligence? So as we've talked about before in other webinars, environmental due diligence, or the world that we live in, uses nomenclature like phase 1 environmental site assessments or phase 2 environmental site assessments. But then particularly for today, we want to talk about the third part of that risk management process, which is if you've got an issue, what can you do about it? What can you do about that risk? We like to package the answer to that in two components: risk assessment, which we talked about in our last webinar, and then this webinar, which is remedial options. If we can go to the next slide. So you'll see this is a slide that's revisited from our last webinar where we talked about risk assessment in conjunction with ecometrics. And that risk assessment process then has built right into the middle of it this idea of properties being remediated and confirmatory sampling being done as part of this overall risk management or risk assessment process. So the risk assessment deals with two things. One is coming up with more appropriate site condition standards for cleanup, and then also where there's issues to be done to be implemented that manage pathways or manage the risk associated with coming in contact or potentially coming in contact with the contaminant. That you come up with a strategy for that, and remediation plays a role in both of those tasks. So it's both integral and very important to this overall risk management process. I'd also like to touch on and again revisit the idea of this all fits within the regulatory environment within Ontario. So this is not something that is outside of that regulatory environment, but in fact it is in fact something that is part of the whole environmental regulatory environment for this kind of work, and is compliant with the things that the Minister of the Environment is looking for. So at this point then, I'm going to switch over and pass it on to Gavin, I think is first, but if we can go to the next slide, and then I think you can pick it up from there, Gavin, thanks.
Yep, thanks, Paul. So once we've decided that remediation will be required as part of a larger risk assessment scope of work, There's a bunch of different things that we have to consider when selecting that remedial technology in order to meet the specific site goals, as well as the client's needs. So the first and foremost, of course, is to select the appropriate remedial technology that will effectively treat the contaminants on site, given the specific site conditions. But there are some other factors as well that you have to consider. The first, as Paul was talking about, we generally couch remediation within a risk assessment process. And one of the big benefits of that is that you only have to remediate down to property-specific standards, which are generated during the risk assessment process. And these property-specific standards are, in general, much less stringent than the criteria that would otherwise be imposed by the ministry. So because of that, you can select perhaps a remedial technology that might be less aggressive, but will still get you down to those property-specific standards. Another factor to consider is the potential for offsite risk. So at a large proportion of our sites, this offsite risk takes the form of a contaminated groundwater plume that's migrating offsite towards a sensitive receptor. So that could be something like a drinking water well, or even just a neighboring property. And so you have to make sure that your remedial technology that you select will be able to mitigate or destroy or at least reduce the risk or remove the risk of this offsite migration, if it exists. Then the other thing to consider as well, as a function of the risk assessment process, you're going to generate risk management measures. And those are basically just procedures to block the pathways of risk towards human and ecological receptors. And those can be relatively complex and expensive if there's significant concentrations of contaminant on the site. But if you can pair that with an appropriate remedial technology and implement it well, you can minimize the need for perhaps as complex risk management measures that you might have had to have or implement otherwise. And then, of course, there's also the trifecta, as Paul likes to call it, of scheduling, budget, and outcomes. So typically, if you're selecting a remedial technology that you want to have a significant impact within a shorter timeline, you're going to have to pay a little bit more upfront for that more aggressive approach. But if you have a little bit more time, you can achieve the same outcome with a reduced budget. Next slide, please. So how does this look like on the ground? Like how exactly do we go about selecting this remedial process? We like to team up with ISOTEC and use something called the Remedial matrix selection process. And what this is, you can see a figure of it here on the slide. This is a kind of a simplified version, but essentially we have a list of factors across the top there. And these are all different things that we think will play a role in remedial success for a given remedial technology. So these factors might include things such as the cost of the remedial technology, how invasive it will be, the health and safety aspects, how applicable the remedial technology is to a specific type of contaminant, which may be on site, and a whole kind of list of other different factors as well that will play a role in remedial success. And then based on the specific site characteristics and the client's needs, we give each of these factors a weighting. So the higher the weight, the more important the factor is in our eyes. And then we screen, or we score each remedial technology across all of these factors, and the technology or the group of technologies that have the most optimal score are the ones that we seriously consider as potential remedial technologies for a site. And the benefit of this is it really just provides an unbiased ranking for different remedial strategies that is specific to each individual project, thanks to the weighting scheme, which is applied to the factors. So next slide, please. Okay, so now we're going to switch gears a little bit and just talk about what you can expect if we apply remediation to a site, especially as a part or synergistically with a risk assessment as well. So next slide, please. So there are, when you're considering using remediation and risk assessment as synergistic tools to achieve your goals for a certain property, there are a lot of benefits. The first we've already kind of discussed before. It's the application of those property-specific standards as opposed to generic criteria, which tends to be a lot more stringent. And so you can kind of you're able to more surgically apply remediation as opposed to applying it as a larger, more costly tool. The other thing that remediation helps to solve are transboundary issues. So of course, your risk assessment and your property specific standards, they only apply to your site or the site that you're interested in purchasing. So you have to make sure that those transboundary issues are dealt with. And that's where remediation can also play a significant role to mitigate that risk. Also, as I kind of touched on earlier during the remedial selection process, if you select an appropriate remedial technology and apply it cleverly to your site, it can be combined with risk management measures to provide an overall cost-effective risk mitigation solution. So next slide, please. Okay, Paul Dombrowski, I think you're going to take it up from here for a bit.
Yeah, thanks, Gavin. So thus far, a lot of the discussion that Paul Wilson and Gavin have, it's been a little bit hypothetical about remediation and risk assessment. So going forward, Gavin and I are going to share some real examples of projects that AEL and or ISOTEC have been part of. And Paul Wilson earlier had said that most of what we're discussing today is applicable to Ontario, but other states and other provinces are also going to have similar risk assessment or circular regulatory pathways. Maybe not exactly, maybe different terminology, but a lot of these lessons and these pathways have value elsewhere too. So we're going to start with an example where ISOTEC's remediation and AEL's risk assessment complemented each other. And it's something to acknowledge is that even with very effective remediation, you still may not achieve a regulatory criteria, particularly some of the more stringent ones that may have low quantitative numbers. But this isn't a reason to walk away from a project or not to do the remediation. It's just something to acknowledge as part of that planning process. So the most important thing when starting the process is to really understand your site, and then when you're going to go down the remediation pathway, to make sure that you take all of the steps and best practices to make it a very effective remediation. This includes implementing a site-specific technology evaluation, like Gavin discussed. Implementing thorough site characterization, so you know where the contamination is and where it may be traveling, what pathways they may be. Maybe it includes bench scale or pilot scale testing. And when these steps get done with a thorough remedial design, that's when remediation can be very effective to benefit the overall process. However, even with a 95% mass reduction or maybe even more, it's possible, as we saw on this one project for trichloroethylene, a chlorinated VOC, volatile organic compounds, we were still, the residual concentration after the very effective remediation was above the criteria. And this is where the risk assessment was an important piece. But that successful remediation, and Gavin started alluding this, opens up more options to the project. Just having lower concentrations or lower residual mass, first and foremost, may make a property more enticing to purchase or to sell. But those lower concentrations pose less risk to human receptors. So that's a benefit too, that just there's less people, less workers who could be potentially exposed. And therefore that opens more opportunities for different risk assessment pathways and or control measures. And those control measures may be simpler, they may be less expensive as well. So in this example, with the concentration shown in the left box, when AEL completed their risk assessment and they generated a project-specific goal, and on this project, based on the specific receptors, that concentration goal was just above 440 micrograms per liter. So this was an example where remediation plus risk assessment equaled no further action and site closure. Next slide, I think, passing back to Gavin.
Yep, this is me. So Paul Dombrowski mentioned the contaminant of concern on the previous slide at our site was trichloroethylene, which is actually a type of chlorinated solvent And we see chlorinated solvents at many of our sites, and they are a large driver for risk at a property. And so we thought we'd just take a few moments just to kind of dive into what they are, and why they can be problematic, and why we have to have developed specific solutions to deal with them. So chlorinated solvents are compounds which are widely used at a variety of industrial for a variety of industrial purposes. These purposes include dry cleaners, industrial degreasers, printing operations. They can be found in adhesives, even sometimes in air fresheners. So they're pretty widespread, and they can cause significant issues. So they are volatile organic compounds, or VOCs, and that means they can volatilize or evaporate into the vapor phase. And once in the vapor phase or the gas phase, they can be driven by pressure gradients from the soil gas into indoor air spaces of buildings. And that causes indoor air quality issues, because there are short and long-term human health impacts associated with chlorinated solvents. And that indoor air issue is one of the main drivers for risk that we see on a site, which we have to then deal with via remediation and risk assessment. And if you're considering that, okay, maybe I have chlorinated solvents in a site, but maybe they'll just degrade over time just by themselves. They unfortunately do not degrade in nature very quickly. They're very persistent unless you apply some sort of a remedial intervention. And the other item as well is that even as they degrade, and I think Paul Dombrowski will be getting into this in the next slide, there are multiple degradation products along the pathway of their degradation to a final harmful byproduct. But these degradation products may be actually harmful to humans as well. So there are some issues there to consider. Anyways, Paul, next slide, and I'll hand it back off to Paul Dombrowski.
Right. So Gavin was just talking about how the chlorinated volatile compounds, one of the challenges is that they don't degrade without much intervention. However, the good news, and I think it's really good news, is that there are naturally occurring bacteria that have been discovered that are capable of biodegrading these harmful contaminants into an innocuous byproduct. It's just that the bacteria need to be given the right conditions for them to thrive. And for these bacteria that biodegrade these chlorinated solvents, those are anaerobic conditions, meaning that these bacteria operate most favorably in conditions where there's no oxygen. So what we can do as remediation designers is we can engineer the soil environment to be favorable for these bacteria. So in the middle here, we're showing a series of steps, and these dechlorination reactions, which are done by the bacteria, happen sequentially, one reaction at a time. And each reaction, bacteria pluck one chlorine off these compounds and replace it with a hydrogen, such that in this process, these chlorinated compounds start with 3 or 4 chlorines and eventually get down to ethene, which has 0 chlorines and is completely harmless. There are a number of different bacteria that are capable of performing the first 2 steps, but there are less specific bacteria that have been identified that can complete the last 2 steps. That's where it's really important to understand the microbial community at your site, and if the appropriate bacteria are there, and steps that can be taken to either enhance or augment their concentrations. And Gavin did allude to on the last slide that some of these intermediate byproducts also can be harmful to humans, as well as have regulatory criteria. So that's something that needs to be considered as part of the process.
Yeah, and I would also just add from AEL's perspective, and I suppose from ISOTEC's perspective as well, because they have been instrumental in helping us with the remedial design. In situ bioremediation is often, if not the sole remedial process, it is often a part of the overall remedial process that we involve for chlorinated solvent sites, because it's a powerful process, and it's also relatively inexpensive, and it's very persistent. So it'll last from, I think, 3 to 5, possibly even longer, 3 to 5 years, possibly even longer, if properly implemented. So we feel it's a very powerful technology, which is why we kind of took the time to explain it a little more thoroughly. So with that, I guess moving to the next slide, please. Okay, so now we're going to switch gears a little bit, talk about some case studies where we apply these remedial technologies. There are 3 case studies we'll get into. Each case study is unique. It has specific site conditions and client goals that kind of separate it from the others. So this first case study, we used a blended remedial approach, and the uniqueness of the site was that it was a low permeability site. So next slide, please. Okay, so this particular property was a multi-tenant commercial and industrial property with 3 buildings on it, which have been in use since the early 1970s. And past and current uses have included generators of waste. And some of that waste has been chlorinated solvents. Primarily, we found on site trichloroethylene, which is that molecule that has the 3 chlorines on it. We had concentrations of trichloroethylene at this site within the groundwater of 50,000 micrograms per liter, which is fairly significant. And as a result of this, there were some off-gassing issues which created indoor air vapor intrusion risk. So because of that, we had to come up with a remedial solution to address some of the groundwater contamination as part of the overall risk assessment process. The challenge here was that, as I mentioned, the soils are very fine grained, which made them low permeability. This low permeability creates a lot of back pressure if you're trying to inject any remediation solutions down into the soils. So that was one challenge. I will mention that throughout Ontario, this is fairly indicative of the soil types, given that we are in a glacial till region. So we do come across this low permeability soil on a fairly regular basis. So while this was a challenge for this site, it was certainly not a unique challenge. Another item with this site, it had slow groundwater flow. And so if you were to inject a specific amendment, the challenge is that it might not travel so far down gradient and impact a larger plume, just because there's that combination of low permeability and slow groundwater flow really slows down or reduces the total distance that can be traveled by groundwater advection of the injected amendments. So next slide, please. Paul Dombrowski, you want to take it over from here?
Yeah, sure. So AEL had implemented a soil vapor extraction system. This was a method to essentially suck out soil vapors above the water table that had high concentrations of the TCE and chlorinated solvents. So that system had been up, it was operating. And so the next step as part of the site remediation process was to initiate treatment for the contaminated groundwater and soils below the water table. And this is where ISOTEC and AEL collaborated on a remedial technology screening matrix like Gavin showed earlier. And on this particular site, one of the categories that had a particularly high weighting factor was long-term persistent treatment. This was a site that had some active components and also relatively high concentrations. So it was desired to have a technology that would continue to treat over a longer period of time. As a result of our technology screening, the best fit for the site was enhanced reductive dechlorination, which utilized the biodegradation processes that we showed earlier. And we applied several different amendments as part of this process. EVO, which is emulsified vegetable oil, which is just that. It's food grade soybean oil, and that provides a food source and also a means to generate the conditions that are most favorable for the bacteria that do the biodegradation reactions. We also applied a zero valent iron, which this is another chemical that's used for direct reaction with the chlorinated VOCs and in order to enhance and accelerate that remediation. And we also performed a bioaugmentation step, which is adding directly bacteria that have been cultured on high concentration of chlorinated solvents. The bacteria that we use for the site are called KB1, and they were developed and they are cultured right in Ontario. So for this project, I really like to call the KB1 our hometown heroes, and they're really kind of doing a lot of the heavy lifting and actually doing the destruction for us. So for the project, before going all in, we designed a small scale pilot test with a relatively small footprint of 85 meters squared. And this was focused directly around the one well that had the highest concentrations of TCE. We wanted to have a site-specific demonstration on the highest concentrations on the site. And if we could treat those, we knew we could treat a larger area as needed. And the pilot test was done with 9 temporary injection points. Next slide. So the pilot test injections were done over approximately 3 days to complete the pilot test. And then AEL performed sampling 2 and 4 months after the injection. So we're just going to talk a little bit about the results, and then Gavin and I will talk about how that pushed the site along. So the top plot here shows the well that had the highest concentrations, more than or 50,000 micrograms per liter prior to any remediation. And we can see that just after 2 and 4 months after the injection, that concentration was significantly decreased, more than 3 orders of magnitude, very rapid reduction. And a lot of that rapid reduction is owed to the zero valent iron, or ZVI, which applies a more aggressive way to treat the chlorinated solvents. But we were also seeing good signs of biodegradation happening as well. We were seeing some of those intermediate products being formed. And we were all even seeing on a well that showed here on the bottom plot here. This is actually outside of our pilot test area. And as groundwater flowed slowly, as Gavin said, but over a period of 4 months, the groundwater flowed from our pilot test injection area to this well. And we can see as the emulsified vegetable oil and the organic carbon that we provided as a food source for the bacteria made it towards this well. At that point, we started seeing a very rapid reduction of our TCE as well, thanks to our bacteria. And then we're seeing the first daughter product form at 4 months, and a little bit of the second daughter product form at 4 months as well. But we recognize that this amendment is going to be active for 2 to maybe even up to 5 years. So we're just setting up the environment in just a few months for the bacteria to continue to degrade. And we're also seeing some other lines of evidence through some formation of iron sulfide in the ground post-injection. And this is another pathway that has similar reactivity to the zero valent iron that we added. So we saw that the pilot test was able to achieve very rapid reductions. We were able to establish conditions that were favorable for biodegradation, and that the processes were working. So we were really thrilled by how the pilot test went, and using this, we transitioned to use the pilot test information to design a full-scale remediation in conjunction with AEL. Next slide, please.
Yeah, so I think this is me again. So yeah, as Paul Dombrowski was saying, we did implement full-scale remediation based on the successful pilot study demonstration. We had equally successful results for the full-scale remedial process. And as a result of this, the property was able to be sold and liability was managed throughout the sale process. So it was a good ending to this story. Next slide, please. Okay, case study number 2. This is a scenario where we had some contaminated lands with a prospective buyer. However, the property was had a lower value. So what do you do when you have a low property value and you can't handle a large remedial cost? Next slide, please. Okay, so this particular property had known chlorinated solvent contamination on site. There was that TCE that we had in the previous case study, as well as a myriad of other chlorinated solvents on the property. Several environmental investigations had been completed previously by other consultants, And as a result of the hefty remedial bills that were associated with those recommendations, the property had been left abandoned to this point. And again, the reason for that is because this property was located outside of the GTA, and so it had a lower property value and could not really support an expensive remedial endeavor. Next slide, please. So when the prospective buyer came to AEL, AEL was able to team up with ISOTEC and provide a 2-year remediation and development timeline. So one of the big considerations for this particular property environmental process was timeline. So that 2-year redevelopment timeline was fairly critical. There was also a full-scale remediation proposal that was put forward in conjunction with a risk assessment process, and the combination of the risk assessment and the remedial working together again synergistically, was able to reduce the price enough to meet both the budget and the timeline, as I mentioned earlier. We were also able to, or there was also potential for the prospective buyer to negotiate with the owner to lower the overall purchase price. So that helped with the cost as well. The client was also concerned about some environmental orders on the site and also with offsite contamination. So that's that transboundary issue we discussed earlier. It was fairly obvious from the former investigations by other consultants that there was a significant amount of contamination that would be migrating or was in the process of migrating offsite. So again, AEL and ISOTEC were able to come up with a remedial solution that aggressively attacked or would aggressively attack that offsite migration and minimize risk. So because of that, and combined with the risk assessment, we were able to offer the client an approach with fairly high certainty of success and a much reduced or lowered risk. So next slide, please. Next slide, Miguel. Thank you. Third and final case study. This had to deal with bedrock volatile organic carbon or bedrock chlorinated solvent contamination remediation. So next slide, please. Okay, so this property was located north of the GTA. So similar to the previous case study, it did have a lower intrinsic property value compared to a property which would be located within the GTA. It has a single site building, which has been used for industrial purposes since the early 1900s. And again, similar to the other sites, and this is a reoccurring theme, there were significant concentrations of chlorinated solvents, or CVOCs, that's chlorinated volatile organic carbons, within groundwater. And the specific chlorinated solvent that was contaminating this site was tetrachloroethylene, otherwise known as perchloroethylene, or PCE. And as a result of these groundwater concentrations of PCE, there were significant also subslab vapor exceedances. So that is tetrachloroethylene, or PCE, as well as trichloroethylene, or TCE vapors that off-gassed from the groundwater made their way up under the building and into the vapor located right underneath the floor slab of the building. And as a function of that, AEL was a little bit concerned that there might be some indoor air issues, but subsequent air testing revealed there were none. So that will kind of tie in as well in the next slide for the remedial selection process of this site. Next slide, please. Okay, so this site, when we teamed up with ISOTEC again to come up with a remedial design. This site was unique in that the majority of the contaminant mass was located within shallow bedrock. Bedrock can be challenging to remediate within just because it's typically fractured or channeled, and there can be significant massive contamination within discrete fractures that are difficult to reach with remedial amendments. So that was one consideration that we had to take when designing the remedial solution for this site. The other thing that I noted earlier, there were no indoor air quality issues, so there's no immediate risk to human health. And so we were able to go with a more long-term, slower, but less expensive remedial process. And that process was enhanced reductive dechlorination, which basically takes advantage of that natural biodegradation that Paul Dombrowski was talking about earlier. We also enhanced that biodegradation with some injections of KB1, similar also to what Paul was talking about earlier. And there were also some abiotic reactions that we manipulated, particularly through the formation of iron sulfide. Another unique thing with this approach that we were able to do is that since the site is such a high permeability, we were able to get away with only a single injection well, which is relatively unheard of. But this was able to significantly reduce the cost and bring that overall budget down as well. So next slide, please. Paul Dombrowski.
Yeah, sure. So this approach was similar to what we applied for the first event, where we applied a carbon substrate as a food source. And in this site, well, on the last site, we noted that there was some evidence of that iron sulfide being formed in situ. On this site, we intentionally tried to stimulate the formation of iron sulfide to get additional reaction pathways. And so here's some of the results in two of the wells where the treatment was performed. One where we saw slightly higher concentrations, and one just a little bit down gradient. As Gavin mentioned, there was only a single injection well, so we were also looking for amendments that had the ability to travel with the groundwater flow. But overall, the results have been quite promising. We see within a period of about 2 months after the injection, the pathways, both the bioremediation as well as the abiotic reductive dechlorination, were seen in both of the wells. The PCE, which was our primary contaminant, rapidly reduced. Notably in the source area well here on the left, we're seeing the presence of several of those lesser chlorinated, those intermediate products that we showed on the slide earlier. So that those products are forming, but then over a period of approximately 5 to 6 months, the bacteria continue to do their degradation. We had the abiotic additional pathway for treatment. And in that total path, we see that pretty much all of the chlorinated solvent contaminants in groundwater have been reduced to near non-detect concentrations. So as a result of this remediation, the project is on a path for a record of site conditions. So yeah, we were very, very happy with the overall remediation results. Gavin's just going to tell you a little bit more about what's happening in terms of the closure.
Yeah, I just add to this. There was a financial incentive provided. This can also be done for these. As I mentioned, this was a site outside of the GTA, so it had a lower intrinsic property value. So in this particular situation, there was a financial incentive provided to the buyer, where there was a vendor take-back mortgage, and the vendor carried the cost of the remedial bill. So we were able to come up with this as a win-win situation, where the buyer was able to take on some of the site as his own property, and at a reduced cost of environmental remediation, and the vendor was able to divest of the property and reduce his overall risk. So next slide, please. Okay, I think Paul Wilson, it's back to you.
Great, thanks Gavin and Paul. So again, we like to reinforce a couple of takeaway messages that even though we may have spent a fair bit of time talking about remediation, we do want to emphasize the fact that these are always integrated approaches. So every site is different, every client is different. Technologies that we bring to the table try and meet those problems where they're site-specific or client-specific. So we do like to make sure that that we offer integrated solutions that that meet your needs. And so with respect to that, we do have a couple of takeaway messages. If we can go to the next slide, right? It's a bit self-serving, but we think it's a good message, which is engage your environmental consultant early in the process. There's a lot of conversation that has to happen in the assessment phases, in the risk assessment phases, in the remediation phases, where the environmental consultant can provide you with valuable insights. Then the next thing is to make sure you have your decision makers at the table with respect to the issue. So those decision makers, they obviously involve the client, they involve the consultant, and they involve the remediation engineers and people that are directly involved in the project. But there's also a very significant component that often we have to have a long conversation with the client around the Ministry of the Environment, or M.E.Sc in Ontario. The Ministry of the Environment, in particular the district engineer, is going to be concerned about offsite impacts, and there's always the need at some point to get engaged with the Ministry of the Environment with respect to your remedial approaches to a greater or lesser extent. So in that context, we often like to talk to our clients about, is it appropriate to engage with the M.E.Sc? What might that look like? And what would the outcomes be that we would like to see? The next takeaway is resist the temptation to walk away from problems. We don't think that there's any site that we cannot address in or bring a realistic solution that's going to bring it back to productive reuse. So if you think that your particular property is an issue that you can't handle, we'd love to talk to you about it and bring some creative problem solving to the table that can then give you some dividends down the line, either by creating value or limiting risk. And don't be afraid to be informed. That's the reason why we put on these webinars. We're always available for conversations and recognize that risks can be managed. Next slide. Which brings us to our question time, pretty much on time, in fact. So I don't know if there's any particular questions that people have. Again, we'd encourage you to use the chat function. If not, we do have a couple of questions that we can raise. So one of the questions that we're often asked is around the idea of how much remediation costs. So that's always a significant question, and remedial costs. We like to talk about those in conjunction with creating value. So in terms of property values that are impacted by contamination, there's really two components to that. One is the liability issue, where you're carrying a liability on a property that is affected by the contamination, and that can be solved with the remediation work. The other part of that equation, of course, is the depressed property value. So in light of both of those questions, the fact that there's an environmental cost and a remedial cost, we generally find that the remediation work creates value in the property. It doesn't depress the value. There is, of course, a direct cost in order to achieve that, and to bring that property back to marketability. Those are always something that we can talk our way through with clients, but there is an issue with respect to cost, then it's usually offset by the value of the property. And it depends on the contaminant, it depends on the geology, and it depends on the location. So another question that we're often asked is, how long does it take? These processes generally take, especially if they're combined with risk assessment, you're looking at something that's a year or two long at least, maybe even a little longer in some instances. We do have projects that are multi-year, but we do try and work them into the process of, if you're considering site redevelopment or things like that, into kind of a common site planning kind of approach that allows it to be dealt with in parallel with some of the other things that happen at a site.
And that's a really good point, Paul, about doing things in parallel. And in my experience, I've been on projects where sometimes getting out to the field, whether there's a property transfer or the like, or there's known contamination or maybe an unknown contamination. Someone buys a property or new contamination is found, and there's projects where after even finding a release, there was in situ remediation out in the field within 6 or 8 months, and that they knew there was other processes. There was going to be regulatory going through the phase 1 and the phase 2 and risk assessment. But by going and doing the characterization, finding the contamination and treating it, when the project went through that process, there was going to be significantly less contamination and therefore less risk and less exposure when the paperwork, risk assessment, or phase 2 process happens.
Great, thanks, Paul. Then in terms of one of the other things in terms of property redevelopment or looking at contamination, we focused on chlorinated solvent contamination, particularly because that's the hardest to solve at the moment in terms of the remedial environment. Chlorinated solvents are particularly difficult, and they have issues that are affected by geology and also by the nature of the contaminant and their presence in groundwater and things like that. So there's a number of things that come into play, but we are able to apply similar kind of strategies to what we talked about today to any of the other what we call buckets of contaminants. So chlorinated solvents are one of them. Just volatile organics in general that might be petroleum based are another one. Metals are another one, and then just petroleum hydrocarbons are another one. And there's strategies that can come to bear with respect to all of those areas of contamination. So with respect to another question that often comes up is whether this blended approach that we've been talking about, combining both remedial technologies and risk assessment together, when you tie all of those things together, does it make sense? Does that cost more? Am I just making what might otherwise be a straightforward problem more difficult? And the answer to that is, generally speaking, blended approaches will give you a solution that's faster, at less cost, and gives you a better product at the end of the day. It manages your risk better and provides you with a better outcome. So in our opinion, it hits all of the project management criteria with respect to outcome, budget, and timing. So we're firm proponents of blended approaches as opposed to going to the path of more generic approaches. It does require that you be a bit more iterative in your process, where things may not be as known up front as you would like, but at the end of the day, we think you end up with a better outcome.
And that provides a more full toolbox approach as opposed to going at every problem with a hammer. Now you may have 2 different size hammers, or a hammer and a saw, or a hammer, a saw, and a wrench, and those tools can be both actual remediation tools, but they can also be risk assessment tools as well.
Right. So if there's no more questions, we'd be happy to chat with anyone offline if you'd like to do that. Otherwise, I'll remind you of the follow-up survey we'd like you to take when you exit. And then also, just to mention, we are looking at for our next webinar, looking at topics that are perhaps along the same theme of risk management, but using different tools like insurance products or legal agreements. So look out for those those webinar descriptions, and hopefully you can join us then. Anyhow, thanks very much for joining us, and we appreciate your time.